This is SpaceTime Series 24, Episode 86. Coming up on SpaceTime, geologic evidence of climate change on Mars, heavy metals found in comets, and India tests its engines for its new manned spacecraft. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Mars Curiosity rover has been studying geologic evidence of massive ancient climate change on the red planet. The new study enriches science's understanding of where the Martian rock record preserved or destroyed evidence of Mars's past, and possibly any signs of life that evidence may have contained. Today, of course, Mars is a planet of extremes. It's bitterly cold, it has high radiation levels on the surface, and it's bone dry. But billions of years ago, Mars was a warm, wet world with streams and lakes that could have sustained life. As the planet's climate changed, one of these many lakes, in Mars's Gale crater where Curiosity now explores, slowly dried out. The six-wheel car-sized rover now has evidence that super salty water, known as brines, seeped deep through the cracks between grains of soil in the parched lake bottom and altered the clay mineral-rich layers beneath. The findings, reported in the journal Science, adds to the understanding of where the rock record preserved or destroyed evidence of Mars's past and any possible signs of ancient life those rocks contained. The study's lead author, Mars Curiosity rover mission scientist Tim Bristow from NASA's Ames Research Center in California, says scientists used to think that once these layers of clay minerals formed at the bottom of the lake in Gale crater, they stayed that way, preserving that moment in time for billions of years. However, the new study shows that brines later broke down these clay minerals in some places, essentially resetting the rock record. Scientists compared samples taken from two areas about half a kilometre apart. Both were in a layer of mudstone deposited billions of years ago at the bottom of the lake at Gale crater. Surprisingly, in one area, about half the clay minerals they were expecting to find were missing. Instead, they found mudstones rich in iron oxides, the minerals which give the red planet its characteristic rusty red colour. Scientists know the mudstones sampled were about the same age and started out the same as those nearby loaded with clays. So, why then, as Curiosity explored the sedimentary clay deposits along Gale crater, did patches of clay minerals and the evidence they preserve disappear? Minerals are like time capsules. They provide a record of what the environment was like at the time they formed. Clay minerals have water in their structure, and they're evidence that the soils and rocks they contain came into contact with water at some point. Previous work had already pointed out that while Gale crater's lakes were present and even after they dried out, groundwater moved below the surface, dissolving and transporting chemicals. After they were deposited and buried, it seems some mudstone pockets experienced different conditions and processes due to interactions with these waters, and that changed their mineralogy. This process is known by geologists as degenesis, and often complicates or erases the soil's previous history, writing down a new one. Degenesis, however, creates an underground environment that can support microbial life, and these are excellent places to look for evidence of ancient life and gauge habitability. By comparing the details of minerals from both samples, Tim concluded that briny water filtering down through overlying sedimentary layers was responsible for the changes. Unlike the relatively freshwater lake present when the mudstones first formed, the salty water is suspected to have come from later lakes that existed in an overall drier environment. Scientists believe the results offer further evidence of the impact of Mars's climate change billions of years ago. This is SpaceTime. Still to come, heavy metal found in comets, and India tests engines for its new manned spacecraft. All that and more still to come on SpaceTime. Astronomers have discovered iron and nickel in the cold atmospheres of distant comets for the first time. The findings, reported in the journal Nature, are based on observations undertaken by 2 teams of astronomers using data from the European Southern Observatory's Very Large Telescope in Chile. One of the study's authors, Jean Manfroid from the University of Liège in Belgium, says he was surprised to discover nickel and iron in approximately equal amounts in the atmospheres of some 20 solar system comets observed over the past 2 decades, even ones which were far away from the Sun. Astronomers know that heavy metals exist inside comets, but what wasn't known is that these metals could sublimate, that is, become gaseous, even in very low temperatures, and then wind up being seen in the comet's atmospheres when they're far away from the Sun. The Belgian team found spectroscopic readings for both nickel and iron vapours in comets more than 480 million kilometres from the Sun. That's 3 times further than the Earth-Sun distance. The data suggest that for every 100 kilograms of water vapour in a comet's atmosphere, there's at least a gram of iron and about the same amount of nickel. And that's unusual because there's usually around 10 times more iron than nickel in the atmospheres of comets close to the Sun. Meanwhile, the second study published in Nature, this one by a team of Polish scientists, looked at the interstellar comet 2I Borisov, finding gaseous nickel in that comet's atmosphere as well. The study's lead author, Piotr Gutznik from the Jagiellonian University in Poland, says the findings were such a surprise they repeated the observations several times just to make sure their spectral readings were right. To find out more, Andrew Dunkley is speaking with Professor Fred Watson, an astronomer with the Department of Science.
Heavy metals in comet vapour. This has just been discovered, and I'm guessing there's a paper or at least some form of study that's come up with this interesting discovery, this interesting find?
Indeed, yeah. There is a paper and lots of press about it as well, because it's a really interesting result. And I should tell you that these studies use the telescopes of the European Southern Observatory down there in Chile, which are pretty well the best equipped large telescopes in the Southern Hemisphere. There are a few other ones down there which are pretty damn good as well. But the 4 telescopes of the Very Large Telescope, they're cracking good. So they were used to make these observations. What's interesting about this is by heavy metals, actually we should perhaps just define that for a minute, Andrew, because astronomers
good idea.
have got a very funny view of what constitutes a metal. And a metal in astronomy is anything other than hydrogen and helium. So oxygen's a metal, calcium's a metal.
Oh, right.
Yeah, it's always been like that. I guess probably since the start of astronomical spectroscopy, the idea of breaking up the light from stars and finding out what signatures of elements you can get in there. But yeah, the metals are anything heavier than hydrogen or helium. So when you talk about heavy metals, you're really talking about what you and I would call metals in normal life, and in particular iron and nickel. And iron is the commonest metal in the universe, in fact one of the commonest elements, and it's because it's a byproduct of the nuclear processes that go on inside stars when they're in their normal adult life. So iron is being created towards the end of the life of the star, actually. Anyway, the bottom line is iron is common, nickel is common. Now, there is an interesting little factoid about this, though, and that is that we find, for example, in the core of the Earth, it's an iron-nickel core, and the iron usually outweighs the nickel when you find it in nature, like metallic asteroids or the core of a planet. It's usually 10 times more iron than nickel, which is understandable because iron's more readily produced inside stars. But in this story, we find that in these comets, you've got more or less equal proportions, and that is unexpected, that there are equal proportions of iron and nickel in the comets. Now, we've known for a long time that comets must have this sort of stuff in their material. Remember, comets are icy bodies with lots of dust embedded in the ice, and that dust includes heavy metals. And the temperatures of these things are typically colder than minus 100 degrees Celsius, so they're very, very cold. The metals normally remain very much as grains of dust, basically, not anything that's vapor. But that's the surprise with these observations, and it comes from groups in Poland and Belgium, I think, are the main centres where the astronomers who've worked on this come from. There are 2 studies, actually. In fact, let me get it right. The first study is the solar system comets, and that's the Belgian study. The second one is our old friend Comet Borisov, which has been looked at by a group from Poland.
Boris,
that's the one, yeah. Both of them have found this unexpected result that the metals turn up in the vapor of the comet, the stuff that's ejected from the comet when it gets near the sun, so that material vaporizes. Now, normally these elements, they vaporize at very high temperatures, 700 degrees Celsius or thereabouts, and we're talking here about minus 100. So what's going on? I should just clarify there that when I say vaporize, I mean they sublimate, and sublimation is the process when a solid turns directly to a gas, which happens a lot in astronomy because it's what elements do in a vacuum, basically. Go straight from solid to gas. It's why on the surface of Mars, which is not a vacuum but not quite, ice doesn't turn into water, it just turns straight into water vapor. So that's the process, sublimation. But the mystery, why is it that at these ultra low temperatures, these metals are turning into vapors? And I think, as I understand the research, I can quote actually from the paper, and you'll see the problem. The paper says unbound nickel atoms seem to originate from the photodissociation of a short-lived nickel-containing molecule that sublimates at low temperatures or is otherwise released with major volatile compounds. Did you get all that, Andrew? Because that's the answer.
Yes, it did.
Yeah.
Okay.
What it means is that the key word there is photodissociation. It's the radiation of the sun hitting these things, and it's a nickel-containing molecule, and basically the radiation from the sun shoots out the nickel atoms. And the same is probably true with the iron. I think that's the story, that it's all about the sun's radiation acting directly on these atoms.
If you'd asked me, Fred, to guess before you told me the answer, I would have said, I'm going to imagine it's something to do with the sun hitting the comet.
Yeah, you see,
that's what I would have said.
You should be an astronomer, Andrew, because you've been mixed up with it for too long. But yeah, absolutely right.
I'll be a journalist. We don't have to think much.
I think that's not quite true, but never mind.
Sorry.
I don't think you think at all, do you? No, I never said that. Journalists, I think, have to think an awful lot. And a lot of them, these forensic journalists and, investigative journalists, they're doing a fantastic job uncovering all kinds of miscreants.
It's tough work, though.
Yeah, it would be.
Don't make many friends.
No, I bet you don't. It's a good job you've got me, isn't it, really?
Yes.
Anyway, going back to that, you were right on the money. It's to do with the sun's radiation. To be honest, I would have guessed something similar, but I think I would have got it wrong. I think you got it right. I would have thought, it's the subatomic particles in the solar wind that do this. And it doesn't look as though that's what it is. It's actually the radiation, the light radiation from the sun. So there you go.
Well, when I say I think it's got something to do with the sun, that's a pretty broad answer.
Yes.
That could mean anything. So that's a journalist at work.
Yeah, that's right. Make it broad. So I guess the nice twist in this is the Polish work that has looked at Comet Borisov, the first interstellar comet that we've ever observed, and found that it's got very, very similar properties to solar system comets. It seems to be like a solar system comet in every way, except it's never been near a star. So it's a pristine sample of the raw material of stars and planets. Really interesting that it's an icy remnant of the gas and dust cloud that solar system, wherever it was formed in. And this work, kind of underlines that.
I'm not surprised the Polish looked at Borisov. It's a very Eastern Bloc name.
It's an Eastern Bloc name, that's right.
I wonder if that's why they chose to look at it. Well, it's just the opportunity presented itself, I imagine. And I don't suppose can we ever figure out exactly where it came from?
Borisov, no, it's kind of a bit of a mystery, really. You can see what direction it came from, but you don't know how long it's been travelling in that direction.
No.
And like our old friend Oumuamua, which came from the direction of the bright star Vega, but when Oumuamua was where Vega is, Vega wasn't there. It was somewhere else because Vega's moving as well. The comets are moving and Vega is. Anyway, so we'll probably never know.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. Still to come, India tests engines for its new manned spacecraft, and China launching more spy satellites. All that and more still to come on Space Time. Well, despite the devastation of COVID-19 on the subcontinent, India says it's continuing with plans to launch its first manned spacecraft on an unmanned test flight later this year. The mission slated for December will test all systems aboard the Gaganyaan capsule and will be followed by a second unmanned test flight either next year or in 2023. Now, if all goes well, the Indian Space Research Organisation ISRO will then undertake the nation's historic first ever manned spaceflight. As part of the build-up to that mission, ISRO has successfully conducted its third long-duration test of the Vickers engine that will propel the core L-110 stage of the GSLV Mark III launch vehicle. The liquid-fueled engine was hot-fired for 240 seconds at the test facility in Tamil Nadu, meeting all its test parameters. This is SpaceTime. Still to come, China launches 3 more spy satellites. And Israel planning a science mission to the moon to help the world's school kids. All that and more still to come on SpaceTime. China has launched another 3 Yaogan 30 spy satellites. The spacecraft, together with a microcommunications satellite, were launched aboard a Long March 2C rocket from the Zhaichang Satellite Launch Center in Sichuan Province. Described by Beijing as remote sensing satellites designed to conduct electromagnetic environmental detection and other experimental operations, the Yaogan 30 are actually signet electronic signals intelligence gathering satellites designed to eavesdrop on the radio communications of other countries. The launch is all part of China's ongoing preparations for war, with analysts now expecting the People's Liberation Army to undertake a full-scale invasion of Taiwan within the next 6 years. Last week, the Chinese Communist Party warned Japan that if Tokyo tries to defend Taiwan from Chinese invasion, Beijing will carry out a preemptive thermonuclear attack on Japan. Since 2016, Beijing has launched more than 135 Earth observation satellites designed to provide near-continuous high-resolution monitoring of areas of interest to China. It's also launched some 84 Yaogan spy satellites. These include highly maneuverable spacecraft equipped with high-resolution synthetic aperture radars designed for all-weather day-night reconnaissance, optical satellites with high-resolution CCD remote sensing cameras giving resolutions down to 0.1 meters, and signet signals intelligence gathering satellites. The launch marked the 380th flight of a Long March rocket, China's largest launch vehicle family. This is SpaceTime. Still to come, Israel plans a science mission to the moon to help the world's school kids. And later in the science report, a new study shows that just 7% of the human genome is uniquely shared with other humans. All that and more still to come on SpaceTime. SpaceIL, a non-profit Israeli initiative whose spacecraft crashed during a lunar landing attempt 2 years ago, have now secured enough funding to attempt a second moon mission. The company says new donor pledges means it's now raised most of the $100 million it'll cost to try for another moon mission in 2024. The new funding comes from South African Israeli billionaire Maurice Kahn, who bankrolled much of the first mission, as well as French-Israeli billionaire Patrick Drahi and South African philanthropist Martin Moschel from Entry Capital. The first Genesis spacecraft, built by SpaceIL with help from Israeli aerospace industries, crashed as it was on final landing approach moments before its expected touchdown in April 2019. The new Genesis 2 mission, as it will be called, will be even more ambitious, with plans for a lunar orbiter to deploy 2 lunar landers. Each of the 60-kilogram landers will aim for a different spot on the lunar far side. Meanwhile, the orbiter will remain in lunar orbit, serving as a platform for educational science activities, specifically designed to allow school kids from around the world to participate in deep space research. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study in the British Medical Journal has found a possible link between the Pfizer COVID-19 vaccine and facial paralysis. The case involves a patient who experienced 2 episodes of facial paralysis, known as Bell's palsy, one after the first and another following the second dose of Pfizer vaccine. Scientists say it suggests that Bell's palsy may be linked to the treatment. The report says the 61-year-old man experienced weak or paralyzed muscles on the right side of his face 5 hours after receiving his first dose of Pfizer-BioNTech, and a more severe episode on the left side of his face 2 days after receiving his second dose. The authors report his symptoms have now greatly improved and the patient is almost back to normal. The potential new side effect follows previous reports of inflammation of muscles surrounding the heart showing up as another potential side effect, those taking the Pfizer COVID-19 vaccine. The World Health Organization now estimates over 8 million people have been killed by the COVID-19 coronavirus, with over 4.15 million confirmed fatalities and some 193 million people infected since the deadly disease first spread out of Wuhan, China. A new study has found that alcohol consumption was linked to more than 740,000 new cases of cancer in 2020. Researchers found that 4% of newly diagnosed cancer cases last year may have been associated with drinking alcohol. The findings, reported in the Lancet Medical Journal, looked at levels of alcohol intake per person per country in 2010. 10 years prior to the cancer case data, in order to allow for the time it takes for the alcohol intake to affect cancer development. They then combined that data with statistics for new cancer cases in 2020. Risky and heavy drinking was estimated to contribute to the highest number of cancer cases. But even moderate drinking, the equivalent of just 2 daily drinks, was estimated to lead to more than 103,000 cases in 2020. That's almost 1 in 7 of all alcohol-associated cases. The study found that men accounted for 77% of all alcohol-associated cancer cases. The largest proportion of cancer cases linked to alcohol were found in Eastern Asia, closely followed by Central and Eastern Europe. But among women, the largest proportion of cancer cases that were attributed to alcohol were in Australia and New Zealand, as well as Central and Eastern Europe. A new study has found that just 7% of your genome is uniquely shared with other humans and not shared by other early hominid ancestors. The findings, reported in the journal Science Advances, are based on DNA comparisons between 179 modern-day Homo sapiens and now extinct Neanderthals and Denisovans dating back to between 40 and 50,000 years. The authors found that an even smaller genome fraction, just 1.5%, is both unique to Homo sapiens and shared among all people living today. Researchers already knew that modern-day humans shared some DNA with Neanderthals, but different people seem to share different parts of their genome. The new research focused on finding out which genes are exclusive to Homo sapiens. There are growing concerns that rainbow lorikeets in northern New South Wales and southern Queensland are becoming paralysed, often fatally, because of some mysterious illness. Scientists with the University of Sydney and the RSPCA are studying this lorikeet paralysis syndrome, which appears to affect thousands of birds between October and June. Researchers are now asking the public to help them identify the likely source of the disease, which is thought to most likely be a plant toxin. The syndrome causes limb, neck and tongue paralysis and an inability to blink or swallow, rendering the birds unable to fly and feed, and therefore to survive. The study, published in the Australian Veterinary Journal, found lorikeets only have a 60% chance of recovery, and their treatment requires intensive care followed by extensive rehabilitation. Based on the pathology, researchers have ruled out an infectious disease like a virus and are instead looking at a toxin released by a plant that only blooms or is fruit during the warmer months of the year. Well, if you like your television, you'll probably be really interested in Samsung's enormous 110-inch micro-LED 4K TV. But it doesn't come cheap. With the details, we're joined by technology editor Alex Zaharov-Reutt from ITWire.com.
Yeah, well, it's 110 inches, so it's huge. It's priced at over $150,000 which is over $200,000. That's right, and it's over $200,000 in Australia. Now, this is a 4K TV. It
That's a bit of a letdown. Why wouldn't it be 8K?
The thing is that micro-LED technology is pretty new, and for them to be able to release a 110-inch model is quite amazing. And look, there's ever more 4K content, and the chips inside the TVs are very good at upscaling. They can upscale 1080p to 4K. They can upscale 4K to 8K. I mean, it took a while for there to be a lot of 4K content, and now there's plenty of it.
What is micro-LED?
So, well, this is a tiny little light-emitting diode, which is separate to and different from OLED. OLED uses organic light emitting diodes, which is why it's called OLED, and they have a limited lifespan, and they're also prone to what's known as permanent burn-in. And they also supposedly are restricted in peak brightness. Now, micro LED, the little LED light, can emit its own light as well, but it's not organic, not in the same way that OLED is. Micro LEDs is a technology that is delivering the same kind of ability for the individual pixels to be their own light source. Normally LCDs will have a backlight that shines through, and when a backlight is shining through pixels, it's very hard to get deep blacks. And so micro LEDs are meant to be brighter than OLED displays. And in fact, Apple has been working on micro LEDs for the Apple Watch and iPads. These micro-sized LEDs are supposed to last for over 100,000 hours. So that's, in theory, more than a decade of typical TV watching. The micro LED is meant to be the successor to the LCD screens that we've had, the QLED screens that Samsung has spoken about, and it's meant to be their version of a better form of OLED technology. And we're going to hear a lot more about it. To see a 110-inch model at 150,000, most of these things start off quite expensive, but within 5 years, it'll just be the standard technology sold in the Best Buys in the US and JB Hi-Fi's in Australia. And people will have forgotten about the old LCD technologies, and they'll all be talking about micro LEDs.
How much is it the LED, and how much is it the processor that the TV has?
Well, it's a combination of the two. Obviously the processors these days are very advanced. You're talking about the latest flagship smartphone type of processors. And Samsung has their own micro AI processor, which is designed to maintain consistent 4K HDR, and talking about bright, vivid, and realistic picture quality. You often see these cheap TVs, or at least you saw them in years gone by, where they said, we have a Samsung panel, or we have an LG panel. It comes out of the same factory that Samsung or LG has. But the difference is in the processor. Processor is what takes all of the video, and especially with things like sport, when you've got balls flying across a field. On older TVs, you would see a ghosting effect, or you would see jerkiness. But on the most modern TVs with the latest processors, all of that is smooth as silk, and the TV can even convert older stuff and allow it to be upscaled to higher quality, or to have HDR type of effect where the picture is of much richer quality. And sometimes you need to have two TVs side by side to really appreciate it. I remember seeing a laser TV back in the mid-2000s, and they had a plasma TV next to it, and they had the laser TV next to it, and the laser TV had much richer colors. And they explained that your brain only really sees these when they're side by side. Once you turn the laser TV off and you start watching, in this case, the plasma TV again, after a few minutes, your brain stopped noticing that it wasn't as bright and as clear as the laser TV was. So, that's why a lot of people buy a $600 or TV, 40, 50, 60, 65 inches for $600 in Australia. It would be definitely cheaper in the US. And you have an amazing TV, which is genuinely better than the TVs from 3, 4, 5 years ago that a lot of people are still using. My brother purchased a 55-inch TV for $150, which probably is about less than $100 in US money, from 2013, and it looks fantastic. But you buy the latest TVs today, they can connect to Xboxes and PlayStations and the latest Blu-ray players to have this most vivid and incredible colors with the smoothest of graphics, as well as very advanced built-in smart TV technology that can have all the Netflixes and YouTubes and other TV apps that we're used to. And a lot of people, though, don't want to spend $5,000 on a new TV, so they'll buy a Google Chromecast with Google TV, or an Apple TV, or a Roku, or one of those sort of devices that can upgrade the smarts of their TV. So, just because Samsung launches a $150,000 US TV at 110 inches, that's like a statement piece. That's the technology that will trickle down and become available in every TV that's sold, within the next decade and probably sooner.
That's Alex Zaharov-Reutt from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.